Okay, so we're going to do day 2 of equivalent trig expressions. So yesterday we looked at finding different ways to represent angles that are within the first quadrant. Today we're going to look at relating angles that are in our second quadrant, quadrant 2, and relating them back to an angle that's in the first quadrant. And how we're going to do that is we're going to look at taking an angle, and it'll be pi by 2 plus theta. Okay, so that's going to be our goal, is to relate something in our first quadrant and taking that angle that's in our first quadrant, adding pi by 2 to it, and that'll put it in our second quadrant. And how we'll start this is let's look at a rotation of pi by 2. Okay, for some of our certain points, for some of our special points that are on the unit circle. So for example, if we drew a circle, okay, and we put on, say, our point pi by 6 or 430 degrees, what are the coordinates of our point at pi by 6? Okay, so we take our coordinates for 30 degrees or pi by 6. So those coordinates are root 3 over 2 and a half. We take that, we rotate that point by 90 degrees. And that brings us up to 2 pi over 3 or 120 degrees. And those coordinates are negative 1/2 and root 3 over 2. We can do the exact same thing if we look at pi by 3. The coordinates for pi by 3 are 1/2 and root 3 over 2. If we add 90 degrees to pi by 3, we're going to be over here at 5 pi by 6 or 150 degrees. And those coordinates are negative root 3 over 2 and 1/2. Does anybody notice anything between the coordinates in those ones that we've rotated 90 degrees? They've switched and went negative. Okay, so if we take an XY point and apply a rotation of 90 degrees, and we can describe that rotation of 90 degrees as being pi by 2 plus theta, we get a coordinate of negative y and x. And we're going to use that to do this, or to draw a picture in general. And what we'll say is that for any point in our first quadrant that has angle theta, it's going to have an xy point. If we take that point and rotate it 90 degrees, so our angle is going to be pi by 2 plus theta, the coordinates of that point will be negative y and x. And we can use that to draw our triangles. So our first triangle in our first quadrant, x and y. The triangle in quadrant 2, the x value will be negative y, and the y value will be x. So we're going to use each of these two triangles separately to get our relations, and then we're going to compare them. So from the triangle, this would be the same one we had yesterday. For any angle, we have x, y, and our radius r. We can get our trig ratios from there. So we know that sine theta is going to be y over r, cos is x over r, and so on. Okay, so we can fill out the rest of our relations from just looking at that first triangle. Now our second triangle is where we're going to get the rotations for pi by 2 plus theta. So we can draw that triangle. We have an R, the value that is going up, so our Y value for this is X. Our X value is negative Y. And we can start getting our relations for this one. So sine of pi by 2 plus theta is X over R. And cos of pi by 2 plus theta is negative Y plus, or negative Y over R. Okay, so we can go through and get the rest of our 6 trig identities. So now we have 2 complete lists of expressions. So from these 2 lists, what can we compare? Are there any that are exactly equal? Sine and cos. So we can say that cos theta is the exact same thing as sine pi by 2 plus theta. So that can be one of our identities. Okay, so we've got those 2 off the list. Are there any others that are similar for that? We can say secant and cosecant. So from here, the rest of them match up pretty well, but they're off by a negative. If we look at, say, sine theta, we get y over r. And if we look at cos pi by 2 plus theta, we get negative y over r. Okay, so what we can say for that is that sine theta equals negative cosine of pi by 2 plus theta. Okay. Now note here that I could have the negative with the cosine, or I could have it over here with the sine. Okay. Personally, the way I want these, I want to be able to compare everything to sine theta, cos theta, tan theta. So I'm keeping all of these ones, the angle in the first quadrant positive, and then just making the other ones negative, but it could be the other way around, just in case you see it somewhere that's a little bit different. Okay, so we can go through and finish off our list, matching them. They're off by a negative, so we put a negative in. And these are going to give us 6 more identities that we can add to our list from yesterday. Now, an example to use this, that we can use for this, is say we have sine of 2 pi over 3. And you can see in a question that's going to say express. We'll say express sine of 2 pi by 3 as an equivalent express sine 2 pi by 3 as an equivalent statement using an angle in the first quadrant. Okay, so we know 2 pi over 3 is in the second quadrant. We want to find an equivalent expression that uses an angle in the first quadrant. So again, taking this, we know that 2 pi over 3 is in our second quadrant. And we want to say, all right, well, 2 pi over 3 is something in our first quadrant plus 90 degrees. So pi by 2 plus theta. We can rearrange for theta, and we'll get theta equals 2 pi over 3 minus pi by 2. And that's going to work out to being theta equals pi by 6. We can use that to write that sine of 2 pi over 3 is the same as sine pi by 2 plus pi by 6. After we've split up our angle into pi by 2 plus something, we go back to our chart and find one that matches. And we look and say, all right, which one? Go back to, okay. And we look at this one and say, this is going to match. That sine pi by 2 plus theta equals cosine theta. So that's the one we're going to use. So we're going to use the identity that sine pi by 2 plus theta equals cosine of theta. And that's going to tell us that sine pi by 2 plus pi by 6 equals cosine of pi by 6. So what we can say here is if we find an exact value of cos of pi by 6, it's root 3 over 2. So we can say sine of 2 pi over 3 equals cos of pi by 6, which is the same as root 3 over 2.